Class, welcome, buenos dias, привет, hello. Today I want to show you some interesting color management inside of the Houdini explosion workflow, which is called ACES workflow, which is used in this example here on the side effects webpage. So you can see we have some nice blasts, some cool trails, some spiky glowing edges, and you can see the shading is pretty well done with the help of the ACES workflow. So how is this been implemented into Houdini 18.5? I will show you when you click on the Go Here link. So setting up ACES using OpenColor.io. What is OpenColor.io? You should click this webpage link here. It's a complete color management solution geared towards motion picture production with an emphasis on visual effects and computer animation. Okay, you can see it ships for After Effects, Arnold, Substance, Unreal, and Houdinov for our Russian friends. It's Houdinov, Verzionskaya, Chesnyatsit, E, and up. Yes, it's up. So, go back to the link and click on the GitHub link. So here you have the different releases and the green code button. Green code buttons are super nice because most of the people who surf on the internet click on green code buttons. Everybody should have a green code button. So download the zip. It takes around, some time because it's almost 2 gigabytes large. And when this is downloaded, you definitely go back to the side effects page and check how you can implement the OCO environment. So extract the content where this configuration files are stored. So now we want to set the variable, the environment variable, OCO $OCO. So copy this, go to your environment file from Houdini and set your path, you can see here, into the Houdini environment file. So once this is done, you go to your Z drive, wherever you put your OpenColor.io, and go to the latest release, to the config, and you set your environment variable here on top, so that in the environment Houdini file it can be recognized. Pretty much here. There you can see we have here the variable and the path to our Color.io configurations. This is how you can put it into Houdini, the software from the future, where Terminator is fighting machines with Arnold Schwarzenegger. Okay, now go to Houdini, go to Edit, Color Management, Color Correction, and you can see we have an OCO config. And we can set this variable here and make it available for our rendering. So make sure OCO config is using the provided path on the color correction tab. And you should have some viewport with Gamma 2.2 in default and with ACES enabled in OCO. This is how you bring OCO into Houdini. And I downloaded the scene from side effects here, and you can see we already have some very nice shading here in the viewport already, looking pretty neat. So how is this done with the shading of ACES inside Houdini? So when you open the file, we have here the ground explosion, we dive into it, and here we have some node tree like I already explained in the first tutorial. It's mostly the scattering on a circle with some attribute noise. And we have a pyro trail path, which is creating the trails for us. So here you can see our trail path friends. Those are the trails recognized by the explosion with the pyro trail path. It then goes into an attribute where the density of our explosion is adjusted with a random value from 1.25 to 0.5, and we have the trail source and so on. But the magic is happening down here in the pyro look, in the pyro bake volume, like it's described here. Understand pyro bake volume. The pyro bake volume node provides controls to enhance the look of a pyro solve in the viewport. It also handles automatic material assignment to best match the rendering result to the viewport display, and is designed to provide a similar interface to the pyro shader. When scattering is turned on, it bakes out a scatter volume that is used by the pyro shader to approximate the look of lighting scattering inside the explosions. This is what we want. We want more realism. So I go to the pyro log, and you can see we have here settings like smoke. We have a density of 5. Density is how thick and how dense the smoke is. We have a ramp which is fairly black with the colors of those values here, and we can see here we have here the smoke. And what's pretty interesting is the scatter node. So in the scatter we have the ability to enable the scattered emission aspect of the volume. Use this for shading explosions. This will generate the scatter volume, which is also used for rendering. Wow. Use source volume to identify the volume that controls this emission. So we have a scale of 450. If you put a 1 in front here, it's becoming fairly high, but you can see it's glowing from the inside more and more. And this is the cool thing when shading in the viewport in real time. You don't need to go to the render view and shade it. You can do it right now with the material connected to your explosion. So the scattering puts the light from inside of the explosion through the volume, where the particles of the energy, the photons, are bouncing in a most chaotic way and release more energy, and in that form light. And this light is then scattered into this glowing here. We also use blur scatter. You can see what blur scatter is doing. When this option is turned on, blurring is applied to the computed scatter volume. The blurring spreads out the emission and mimics internal scattering of the emitted light. So we have a step of 3, a fall off of 1. And we use a mask to mask out this blur scatter amount. So we also use fire here. Fire is the element in the explosion that mostly creates the fairly look of the explosion. And we have a value of 450, and when I put a 1 here, you can see nothing is happening really. So it's mostly created by the scattering. And we want secondary fire for our trails, which are generated later in this explosion here. So use secondary fire if you want to enhance the look of the trails your explosion is creating. Then they mostly get little glowy edges and look like projectiles or shrapnel or something like that. So I will do a flipbook for you to see all the beauty of this explosion in the viewport with ICO and ACES enabled. So to make a flipbook, for all those who have no idea how to make a flipbook, we have this little flipbook sign here in the left corner, and we go with a right click, flipbook with new settings, and we want to make the size to HD 1080, and we have $RF start to start at our timeline. $RF end is the end of the timeline. When you increase this here on a button you can't see, then it's getting automatically adjusted. So let's go back to the flipbook with the right mouse button, and you can see now we have 250 images at a resolution of 1920 times 10080. Okay, now let's cook this on this little 468 machine with 266 megahertz. So boys and girls, welcome back to the tutorial here, and you can see we have already 45 frames in our flipbook, and it's looking pretty decent at the moment. You can see the trails and the different impacts happening, forming together to a bigger explosion. And we also can see that the shading is very promising. So, to show this explosion in its whole beauty, you definitely should go and cache your explosion out to disk. How this is working, I will show you now. So here under the Pyro solver, we can see that we have some value of 0.1.5 for our voxel size. So the voxel size pretty much is the value for the detail and the size of our voxel which forms the explosion. A voxel is nothing more than a volumetric pixel. So voxel stands for volume pixel, which means it has depth information. Depth means that we don't have only two coordinates like x and y, but we also have z components which allow us to make it three-dimensional. So for our caching, I want to put the value down to something like 0.5, and I want to go to the sim file cache node, where you here define your geometry file path with bgeo.sc. bgeo is the file format for simulations in Houdini, and it's taking here the $hip means the hip file you can adjust in your work settings for the project, where the project is located. And I want, in that case, save it to disk in the background, which helps you to continue your work and the workload is not completely on the simulation. So to make this happen, first save your file and hit save to disk in background. So when hitting save to disk in background, a shadow will pop up from Houdini, and tell you how far the simulation has gone and how many % are written out to your hard drive. So like I also told you in the first tutorial, make sure you have a decent amount of capacity available. So we open the shadow well here, and you can see it's counting with this clock how many are created, and you can see here we have the file path where it's located. So let's run this for some time. I will come back and we will see how this explosion turns out with a higher voxel value. Keep always in mind it takes more calculation power, so a 268 machine with 2 MB RAM will not last. It will maybe help you to play Comanche, the old voxel game with the helicopter from the 90s, but in our time we want to make some decent explosions. So stay tuned when I come back.